Hi, it's Mike Stevenson here. Today in this video we're going to talk about a question we had from a customer where they had a cost spike associated with logging and API management, and we're going to look at how we investigate and troubleshoot that problem. Before we jump into the video, quick thanks to Turbo360 who support the channel and help me produce some of the videos. They have a tool to help with cost management and with your cloud operating model to help do monitoring and management of Azure solutions. Now let's jump into the video. So we start off with the customer reached out because their FinOps tool had raised an alert, and you can see down at the bottom here we've got some anomaly detection alerts getting fired, and they also were starting to break their budgets each day up at the top over here. But the anomaly detection alert, sort of here it's saying it thinks the root cause is potentially a log analytics workspace where they've got a spike in costs, and it's costing $221 a day at the moment. So the question is, how do we go about troubleshooting this to work out what's driving that cost increase? So the alert here that we can see is this was the alert that fired. So they get an email, or some customers might get a Teams message, for example, and you can see again it's flagging up the root cause, and we've got that 23% spike in costs here. Now, what we can do is we can start looking at the costs that we spend on our Azure environments. This was an integration team, and this graph shows how much are they spending across the month, grouped by the service type. So you can see here where we're looking at, in particular, we're looking at log analytics. And the bit that really flags up here, we're looking at the pattern of spend across the month. And we've got this sort of funny blob shape where the cost of log analytics has spiked for a few days, it's maintained, and then it's dropped off again. So the thing that we've got to think about here is this a one-off cost, what was driving it, but also may it come back in the future and happen again? So we need to understand what caused it, but also if there's things we should tune to reduce the risk of that happening. Now, if from the previous graph, what you can do is you can right-click into these areas. So we could right-click here, open up a new graph where it looks at those log analytics costs. And in this case, we were driving it by the particular resource. So this shows us a list of all of the resources that were log analytics that this customer had in their integration team. And it's pretty obvious here. You can see this is one resource has suddenly had this big spike. So it's not across all the environments. It's really this one particular area. And in this case, the two notable things were the log analytics workspace is one that's used by the logs from API management, so that helps us zone in that it's something to do with API management. And also it was notable that it was in the UAT environment, so it wasn't actually a production issue, it was UAT, which again makes that more suspicious. So the next question is, how do we take this further and work out what's going on? So at this point, we go over to the log analytics workspace, and we can use a few queries to help dig deeper into this. The first thing I want to do is kind of verify that the spike in cost is related to an increase in activity here. So there's a table we can see called usage, and we can put this query in where we're looking for the billable data and how much data are we actually logging to log analytics. So in this case, it's likely that these logs probably come from API management through App Insights into log analytics under the hood. And we can see that, I think if I remember right, the custom date range was only a day. And you can see we've got 89 gigabytes got logged on that day. Now, we also used a slightly modified version of this query to sort of summarize by day how much is getting logged. And we could definitely see a big increase in the amount of data getting logged during this period, so we know that that's what's driving the cost increase. Now, the next question is, how do we go deeper and start working out what's making this increase in traffic? So we can take the same query, and what we're doing here is we're trying to look for which table is it that's driving the change. So here we can see we've got the list of tables across the bottom, and the two big ones are app dependencies and app requests. The other tables haven't really changed much. So what we can think about here is what's the solution likely to be doing. So in API management, we get requests come in that get logged to App Insights, and then we also have dependency calls to the back end that the API proxies, and they're probably getting logged as well. And that would drive traffic on those two tables that we're looking at here. So I think the next question is how do we go deeper again and work out where that traffic's coming from? So here we've got a query that I could use where I'm looking to expand the API name and operation and just do a summary. And I think, again, we were looking at a 1-day window here. So I've obviously hidden the names of the APIs and stuff, but the big one that was noticeable was this here. The rest of their traffic in this environment was very low. But on this particular day, we've got about 14 million calls to this one API, which seems suspicious in a UAT environment, especially when they weren't really expecting to be doing much testing. So we need to work out what's going on with that particular API. If you think we're just sort of narrowing the scope, standard troubleshooting practice here is you're starting with quite a wide scope. What can you do to narrow things down so you start honing in on where the problem is? So now we know which API it is. And then the next thing we can do is we can use this query up here. So here I've limited it to just this one API. And I'm looking at what are the number of requests that we're getting. So let's see if this matches the cost spike. So you can see here on the 30th of August, we've got this big increase in the number of messages. And then we're looking at the number of calls per hour, sort of fairly consistently hitting about 600,000 an hour. And then in early September, it tapers off again. So what's interesting here, the first thing is that they're using in their non-prod environment, they're using the developer SKU of API management. So it's quite cool that it's handling quite a lot of messages there, which is nice. They haven't had any performance issues raised by the project team during this project, saying there was any performance issues or anything like that, again, which is a good one. And it's really, the problem here is that because you didn't have any errors and because you weren't having performance problems, nobody noticed that the cost was creeping up until the alerts started kicking in and people started looking at what the alerts actually mean. So here we can see we've got this definite increase in load here. Now, one of the questions is that doesn't necessarily mean it's going to drive that amount of traffic into App Insights. Obviously there is a correlation, but depending on a number of settings that you tune, that can increase or decrease the amount of data that you're logging. And I think as well as that, we also need to think about what is it that's actually being logged by these calls. So the next thing I did is we can use this query here and we can look at this individual API call. We'll just take the top 10 most recent requests and have a look. What does the log message actually look like to see if it gives us any flavor of what's going on? So the two notable things for me here are, number one, we've got request bodies getting logged and response bodies. And also we can see from them the measurements, the response size and the request size down here. So that response size, 2040 bytes. But if, not huge, but if you think about that multiplied by the number of requests we're getting, and it's possible, if we've got the dependencies there as well, maybe they're even logging the dependency calls with message bodies. So we might be actually copying these requests and responses 2 to 3 to 4 times. And if you multiply it up, that size times that number of calls, that starts giving us a really good indication that this might be the problem here, because that'll, size it up, that amounts to the amount of data being logged, which drives the cost. So the next thing we can do, taking a similar query, and what I've done is I've actually extended the request and response size fields. And we run a similar query where we're looking at the sizes rather than the number of requests here. So you can see the blue line indicates the request sizes are all quite small, but you can see here the amount of data getting logged from that response size. Again, it's fairly significant. We're getting up to a large number here. So I think this is really starting to hone in on that. This is actually the problem driving our cost issue. So If we think about what's actually happening here, so their architecture was that we've got an on-prem application and we've got this new SaaS application that they've purchased. And the problem they had is they need to execute from the SaaS application the API on premise, but they didn't have a way to be able to have line of sight to that app. So what they did is you put API management in here, which they already had. Calls can come into API management from the SaaS app. They've got this network connected, and you're able to reach through to the back end application. As I say, they they had a. I'm assuming there's probably some job in the background, maybe doing like a data migration or doing a big refresh of data, driving all of those calls. But actually, they just work because they haven't really had many errors. They haven't really had any performance issues. But what's really happening is API management for all those requests is pushing stuff out to App Insights. Can't spell. And that then, under the hood, is storing the data in Log Analytics workspace. And then that Log Analytics, the increase in traffic, is driving our cost problem. So what we need to think about is there stuff up in API management that we can tune that would optimize what we're logging to drive the cost being more sustainable. So if we have a look over in the API here, so this screenshot's from API management. We're looking at the settings blade on the API itself. And the thing that jumped out is they had it configured for App Insights monitoring. But the first thing is you notice that these front end and back end requests that all log in the message body. And then you can see here the sizes are configured to be quite large. So I think what actually happened for them is when they first set this up in test, they had a few issues doing some functional testing. So they put the login of messages on to be able to see and troubleshoot any problems. So if they had an issue, they could go and get the message out of API management and troubleshoot it. The problem then was that once that was working, the project teams then powered ahead and started doing some significant amounts of load, performance testing, and migrating data and that kind of thing. But the issues that they didn't have a problem, so they never actually really communicated with the integration team. And it's not until the cost spike kicked in, the integration team have sort of realized actually we've potentially got an issue here, not a functional issue, not an operational issue, but actually a cost spike. So what the solution's going to be is one of three things. Either number one, you just turn off all of these message body logging. That'll take most of the data out of the events. You'll still get a lot of events logged, but they should be much smaller in size. That'll again reduce the cost. You do trade off. You don't need these. You don't have those message bodies, so you could potentially turn them on when you need them if you're troubleshooting an issue. Or the other thing is they could just reduce the size of these to be much smaller, so they may only take the first few hundred bytes or something like that, and that'll again reduce the size of the data, and that'll save them some money. The third option is that they can just turn off the logging altogether if they wanted to, so that's a more invasive issue. If you have some troubleshooting problems, you wouldn't be able to mine that data like we did. If it was a different kind of problem you're troubleshooting, they can also turn on sampling in API management. So I think their settings were like log everything, whereas you could tune that down to log a smaller percentage of requests. That would mean you don't log as much data. So really where we've got to here is we've started with our FinOps tool. We identified a costs anomaly. We went and mined that cost data, gained the insights to help us work out where that problem's coming from. We worked out it was a log issue, so we went and looked at some queries to help us work out what is it that's driving the traffic on the login. We then go to API management and we can make a configuration change to reduce that. Now, the customer probably has to chat to the team for that project to work out, was the load actually valid that the application was querying, because maybe there was a bug in the application and it's just pinging the API constantly. I would guess that it was probably a migration activity because it was a sort of a spike for a few days and then it backed off. But it could happen again, if they do whatever they did, again, they'll have the same problem. So we definitely want to think about tuning this login and API management so we don't get an unexpected cost spike. And we probably want to make sure we're proactively responding to our anomaly detection alerts more quickly. I think the customer waited a few days before really acting on this. But hopefully this gives people a good bit of insight as to what you can do in this area, and I hope you enjoy this video. Thank you for listening.